most commonly processed type of object by computers is text. Text is stored in a Python object called a string, string being a string of characters. So today we're going to learn something about strings. Strings are actually quite complex objects. We'll scratch the surface here and we'll add things a little bit at a time. So let's go ahead and see an example of what a string looks like. So I'm going to make a variable called name, and I'm going to set it equal to Morrison. And hit enter. Okay, so name is Morrison. Now, when you make a string, you can use double quotes on both sides, or you can use single quotes. So let's make a single quoted string and see what that looks like. Python by default echoes back with a single quoted string. Okay, so this is a single quoted string. Here's single, here's name. All right. Now, strings are pretty smart because there are things that we can do where we can get pieces out of strings or get information about strings. One of the most fundamental pieces of information about a string is its length. So if I type len of name, it will tell me that string is 8 characters long. Len of single, quite a bit longer, is 30 characters long. So if you want to find the length of a string, you just say len. You use the Python built-in function len. Now, one thing you're going to want to do with strings is get characters out. And let's talk about that a little bit. I'm going to go like this. I'm going to say name square bracket 1. That got the letter O out. Now, you might be surprised and think, wait a minute. It's the first character in the string. So it should be M. But let's move one to the left and see what happens. Name square bracket 0 gives you what is in fact the first character in the string. Now, here's how I would encourage you to think. These numbers that enumerate the characters in the string, square bracket 4, are called indices. And where do the indices in a string live? They don't live with the character. They live in between. So index 0 is just to the left of this M. Index 1 is between M and O. Index 2 between O and R. Index 3 between R and R. Indices are like rats. They live in the walls. And if you think about them this way, then life will be better for you. You will see that. In fact, there are other types that have indices in Python, and you'll see that they function in a similar fashion. Now, why might I say they live in between? Because watch this. I'm going to say name 1:3, close square bracket. That gets out a chunk of the string Morrison. Now, index 1 lives between the M and the O. Index 3 lives between the O and the R. So everything from index 1 to index 3, you get a copy of that. So it takes that string and gives you a copy of that string. Now, while I'm here, I may as well say this about strings. You cannot do this. Strings are an example of what is called an immutable object. Immutable objects are written on memory in ink. Once you create that object, it cannot be changed. Now, here's a reason to understand that variables in objects are different things. Watch this. I'm going to say name is equal to Roberts. what happened. What happened is this. The string Morrison got created in memory, put someplace. Then, in this line, the string Roberts got created in memory, and name is no longer pointing at Morrison, it's pointing at Roberts, and Morrison is an example of what is called an orphaned object. So that string is orphaned and is now inaccessible. You can't refer to it any longer. The only way you could is if you had two variables pointing at it and you moved one away. So when you change a string that a variable is pointing at, you're not changing the string, you're changing where the variable is pointed. A new string is created in memory and we point there instead. The same thing, incidentally, is true of integers. If I make an integer x equals 5, that's an object that is written in ink and memory. And if I go x equals 5 plus x, what happens here, I evaluate the right-hand side and 10 comes up. And then what happens over here is x is now going to point at 10 and 5 is going to be left behind. So strings and all of the number types have this in common. They are immutable objects. You only can have a variable point at a new variable or new value by reassigning it. Okay? So strings and numbers have that in common. They are immutable objects. Now, let's talk about some other things you can do with strings. Strings have a richer supply of what are called methods than numbers do. And here's an example. To use a method, you say the name of the string and then the name of the method. So say I go upper. What happened? Every letter in Roberts got uppercase. Name.lower. Everything in Roberts got lowercase. So, and let's try this. Name.index, or no, name.find of E. And don't forget to put the E in single or double quotes. And also note the same type of quote, oops, should be used on both sides. I got an error because I accidentally hit the enter key. So check this out. And you will see that E is at index 3. So strings have lots of these things called methods. Method, of course, depends on the string that's being pointed at. If I make name point at a new string, say Caterwall, then the upper method is applied to Caterwall. This is interesting. A string is an object. Now, I may as well say this here. Objects have three important aspects. They have state, identity, and behavior. And to make it very, very simple, the state of an object is what an object knows. A string knows the character sequence in it. The characters in the order in which they appear. What is a string able to do? Well, it can uppercase itself. It can find things within itself. In fact, you can even do this. Watch this. Name.find. Notice that find needs additional information. Let's try BE. Oops. That's not in Caterwall. So that's a sentinel value telling you it's not found. But let's go after ER. Name.find of ER. And it'll tell you the index at which the substring ER is located. It must be a contiguous substring. Now here's another interesting feature. There is a relational operator for strings called in. And if I go like this, if I go cat in name, cat is a contiguous substring. of name, which is now caterwaul. Therefore, I get a true. False. Now, say I type CAE in name. That returns a false because even though the characters C and A and E appear in order, they are not contiguous. So this is a new operation in. In will tell you if one string is a substring of another. It returns a Boolean true or false. Now you might ask, what are the relational operators going to do to strings? Well, let's try this on for size. I'm going to say aardvark is less than beagle. And it's going to say true. And you would quickly come to the conclusion, hey, there must be something alphabetical going on here, right? Let's see if beagle is less than canary. Oh, and I need to put that in quotes because it's a literal. Beagle is less than canary. Okay, now I'm going to do something kind of interesting. Zebra is less than, oh no, here's what I want to do. I want to do capital zebra. Come on, capital. Ew, that's kind of an ugly surprise now, isn't it? What is happening here? Apparently, the order is not alphabetical. Now, one thing you should know is that characters that you see on the screen are an illusion. They are actually stored as numbers. They are stored as bytes. Every character has a byte value. Python has a very nice little function, ord, which will tell you the byte value of a character. The byte value of A is 97. The byte value of cap Z is 90. Oh, what is happening here? Well, this goes back to computer history, and here is the history. Originally, computer languages were done in all capital letters. And then people decided, you know, it might be kind of handy to be able to process non-capital letters. So the character set was added to. And so what they did is they added all of the lowercase letters after the uppercase letters. Now here's a very interesting thing to see. Watch this. Bin of ord of A. So we're going to turn this into a binary number. It will tell us, oh, okay, now watch this. I'm going to go bin of ord of cap A. All right, and I'll put my parenthesis here so things stay pretty. Now, the sharp-eyed of you out there will observe this. Notice the only difference between small a and cap A is that 32's bit. If you flick the bit, the 32's bit, you change the case. If you make that bit a 1, you lowercase the letter. If you make that bit a 0, you uppercase that letter. That is a very fast, very cheap instruction. And so you'll notice all kinds of patterns like that in the bit values of characters. Now, if you want to know everything about this, here's where you go. In Wikipedia, you can look up ASCII. And you can also go to ASCII-table.com. ASCII is a standard for encoding characters as numbers. Because as you know, everything in the computer is nothing more than a stream of zeros and ones. So the relational operators do not alphabetical order. They do what I call ASCII cographical order. So it's a dictionary ordering, but it's done, the characters themselves are ordered by their byte values. I think that'll be about enough about strings for today. Now, what we'll do next time is I'm going to show you the Python built-in object documentation, and I'll show you a valuable place to look for information about strings.